Very few people know the names of the real stars, the stars in the sky. The media tells us everything about the lives of Hollywood stars, but the stories of the real stars are ever more interesting, more exciting, and more relevant to our lives than most of us imagine. Welcome to the fascinating revelations of the secret lives of stars. A night ends and the stars fade. The sun rises as our planet turns us toward it. Sunrise, we say, but it's actually starrise. The sun, at 150 million kilometers distant, is the nearest star to us. Its light takes 8.5 minutes to reach us. It's the light and heat from the sun that allows most life on Earth to survive. Like all stars, it's a giant nuclear explosion releasing vast amounts of energy. The balance between its own gravity and this explosive force shapes it into the disk we see in the sky. Seen in close-up through the eyes of various spacecraft, its explosive nature is very obvious, as is its true size, 1.4 million kilometers across. That's big enough to put 1 million Earths inside. The surface temperature is just over 5,500 degrees Celsius, but at its core, where nuclear fusion occurs, it's around 15 billion degrees. The sun is big and bright because we're so close, but what would it look like from the distance of the next closest star to us? Let's do a little star trekking to find out. Using this fantasy warp factor, we've traveled 275,000 times farther than the Earth is from the sun. We're at a multiple star system known as Alpha Centauri. If you know the star patterns, the sky doesn't look all that different than it does from Earth. There's the familiar W shape of Cassiopeia. And here is one extra star. That star is our sun. It's just an ordinary star among thousands of others in the sky. And it's now 41 million kilometers, or 4.5 light years away from us. Let's boldly go again. This time, we are hundreds of thousands of light years away from the Earth and Sun. We're looking down at the Milky Way, our galaxy, a collection of about 200,000 million stars to which our sun belongs. Our star is impossible to pick out. We know it's about 2/3 of the way out from the galactic center. Just as a forest contains old trees, saplings, dead wood, and new seedlings, so a galaxy contains all types and ages of suns. In some places, new stars are being born. Other older stars are living out their lives, often in groups. And there are remnants of once mighty stars that are no more. You might ask, how do we know so much about these very distant objects? A rainbow holds a clue. Rainbows form when sunlight passes through drops of water in the atmosphere. The water breaks up light into its individual colors. Visible light is just a tiny part of the radiation we can observe from distant stars. The spectrum. Studying a star's spectrum can reveal many of its secrets. In this map, we know that stars vary considerably, both in size and temperature, and that these traits are related to a star's composition, age, and most importantly, its mass. Massive stars have short lifetimes, while the least massive have amazingly long lives. Live fast Die young is the rule here. Most mutants are stars smaller and cooler than our sun. Some can live for trillions of years, consuming their nuclear fuel, hydrogen, very slowly. Our own sun, larger, hotter, and brighter, will use up its fuel over 8 to 10 billion years. This star named Sirius, with twice the sun's mass and 26 times brighter, will last only hundreds of millions of years. It's the brightest star in the sky, but only because it is a mere 8.5 light years away. This star, Rigel, is nearly 100 times further away, has 20 times the sun's mass, and is 40,000 times brighter. It will live only for tens of millions of years. Some stars with lifetimes of only 1 million years or less could be up to 150 times the mass of the sun. Probably the biggest well-known star is Antares, a red giant which, if placed in the solar system, would engulf all the planets as far out as Jupiter. It's a star near the end of its life, a stellar time bomb, a future supernova. From Earth, Antares is a brilliant red star in the constellation of the Scorpion. It lies in the direction of the center of our Milky Way galaxy. Seen through the eyes of giant space telescopes, the vibrant central region of our galaxy contains vast clouds of cool gas, dust, young stars, older stars, and the debris of dead stars. This is the still expanding remnant of a star that exploded as a supernova thousands of years ago. In Earth's sky, it covers an area as wide as 8 full moons. This more compact remnant is of a massive stellar explosion that occurred 400 years ago. A supernova is the explosive death of a star. Its fuel consumed, energy creation stops, the star collapses, then rebounds to blow itself to pieces. It's supernovas that form the heavy elements of the universe, elements needed for our planet, our technologies, and our bodies. If the star is not massive enough to form a black hole, a tiny spinning neutron star forms, just a few tens of kilometers across. It has tremendous gravitational and magnetic fields. As it spins, we get a rotating beam of radiation, a series of pulses, hence the name pulsar. This star, Rigel, is a prime candidate for self-destruction relatively soon as stars go. It's a supergiant about 800 light years away and 70 times the width of our sun. From an imaginary airless world hundreds of million kilometers distant, Rigel would be a breathtaking sight, as brilliant as 40,000 suns. Closer now, the view is awesome. Observations show that Rigel appears to be billowing great amounts of its material far out into space. This continuous loss of its mass just might prevent Rigel from exploding and enable it to end its days as a tiny black dwarf star, surrounded by a vast red. So while it is still there, why not catch it in the famous constellation of Orion? This churning mass is Betelgeuse, a red supergiant star second only in diameter to Antares. Betelgeuse also is in the last moments of its life. It could explode any time between now and the next few million years. When this happens, Betelgeuse will become nearly as bright as the full moon. Betelgeuse is located opposite Rigel in the shoulder of Orion. A cloud of gas in space is called a nebula, and the one in Orion is the brightest in our sky. It's the home to hundreds of young stars, most just a few million years old. Radiation from these hot young stars causes the gas to glow and sculpts the canyons and towers within the cloud. Many stars here are surrounded by dark disks of material, perhaps early planetary systems. From a planet within this stellar nursery, brilliant young blue stars will dot the sky. They will shine like celestial gems against the surrounding gaseous clouds. Five times more distant than the Orion Nebula, this is the famous double cluster in Perseus. The clusters are about 300 light years apart. These are young stars, no more than 14 million years old. In 100 million years, they will open up more and could resemble the famous Planetarium star cluster, better known as the Seven Sisters. From some of the youngest stars, we move to some of the oldest, far older than even our galaxy. When the Earth was forming almost 5 billion years ago, these stars were already 7 billion years old. These oldest stars are found in globular clusters, the spherically shaped collections of stars that orbit outside the center of our own galaxy and many others. They contain many densely packed millions of stars. From an imaginary planet in a globular cluster, perhaps 13,000 stars would dominate the sky. Planets here are extremely rare. Stars have not exploded to form the heavy materials needed for planetary formation. In the constellation of Omega lies an intriguing star, Epsilon Aurigae. As seen from Earth, every 27 years, a strange eclipse occurs. The star dims and brightens over a 2-year period. From nearby, it must be an amazing sight as a huge dark disk, 800 million kilometers across, passes in front of the central star. The Spitzer Space Telescope revealed its secret, a huge dark disk surrounding another orbiting companion star. The disk is apparently composed of very small particles about the size of a grain of sand. This material may have accumulated from the parent star that is actually dying, even though it's shining as brightly as 140,000 stars. Stars whose light output changes are called variables. Our in Perseus was the first eclipsing variable star to be discovered. On Earth, its constant winking led to the name the Demon Star. Measurements of its regular changes led to the discovery that it is actually two stars, regularly passing in front of each other as seen from Earth. So close are these stars, about 8 million kilometers, that one is pulling material away from the other, and the whole system is active with radio and X-ray flares. Unlike our body, matter is variable because it actually changes in size. It brightens and dims by a factor of 1,000 over an 11-month period. Later in its life, our sun will behave like mine, both ending as tiny white dwarf stars, even smaller than the Earth. As it moves through space, Myra is losing material that forms an immense gas trail over 14 light years in length. It has a distant orbiting companion around which planets may be forming. Although no Earth-like planets have yet been discovered, hundreds of planets have been found orbiting nearby stars. It seems that star and planet formation go hand in hand. Planets in distant galaxies are too far away to be detected, but signs of star formation are easy to find. In the October skies from Earth, we can see, even with the unaided eye, the nearest big galaxy to us, Andromeda. Perhaps twice the size of our own Milky Way, it takes 2.5 million years for its light to reach us. Close images of the Andromeda galaxy clearly show the great clouds of gas and dust where stars are formed. In this small galaxy, the clouds of glowing pink hydrogen gas are easily visible. In galaxies near and far, these telltale signs of star formation can be found everywhere, as can stars in every stage of their lives. These observations show that our ideas about the secret lives of stars hold true throughout the visible universe. We're back in our own galaxy now, looking at the biggest star-forming region near us. About 1,200 light-years from Earth is this giant cloud of gas, dust, and young stars. Astronomers call it a molecular cloud. It covers a large part of the area around Orion. This one, 5 times farther away than the Orion Nebula, is bursting with the light and energy of young stars hidden within. This immense cloud could stretch from our sun to the nearest star. From afar, these clouds look dense, but in reality, they are almost a vacuum, and so can be easily pushed and pulled. The exact mechanisms that give birth to stars are not fully understood. It's believed that nearby exploding stars have a role to play in this process. Their shock waves are thought to trigger the gradual compression of the hydrogen-filled molecular clouds, pushing them closer together. Over time, as gravity collapses the clouds even more, their core temperature and pressure get so high that nuclear fusion occurs. In this process, hydrogen atoms fuse to form helium, releasing enormous amounts of energy. Often, these young stars shoot great jets of material into space. At some point, the outward explosive force of fusion and the inward pull of gravity balance each other, and the stars form. Cooler materials around the young star then start clumping together to form the bodies we call planets. They differ from stars in that they don't generate heat and light through nuclear fusion. They only reflect light from their parent star. Here, the Hubble telescope reveals a newly forming star system in this 3.5 light-year long finger of molecular clouds. The jets from a young hidden embedded star reveal its presence. After millions of years, such star-forming regions would look like this, the Rosette Nebula. Hot young stars emerging from the dusty, gaseous cocoon in which they first ignited. Multiple star systems are very much the norm. Some make the most unusual scenes in the universe. This twin system in the constellation Lyra has 2 stars orbiting so close that their mutual gravity has distorted their shapes. Material exchange between the stars forms a complex spiral, winding around the companions and swirling through space. few years ago, a dim star suddenly became 600,000 times brighter. Its light gradually illuminating nearby gas clouds. This was a stellar collision on a Hollywood scale. We had just witnessed a real cosmic smash-up as two stars plowed into each other with brilliant results. In certain systems where material is being pulled off one star onto the surface of another, massive nuclear detonations can occur. So, let's move to a safer distance. This looks like the scene of a stellar detonation, and although this is the ghostly shroud of a dying star, it is not the result of an explosion. It formed slowly over many tens of millions of years. Speeding up time over the next few billion years, the sun will change as the nuclear process in its core alters. Gradually, it will swell up, perhaps getting up to 150 times bigger than it is today. It will spread more and more heat through the solar system. Ice worlds will melt, and the atmospheres of the giant gas planets will boil away. Earth's oceans will vaporize, and our planet will transform into a roiling desert. Fortunately, we will have a few billion years to prepare for this, but it will certainly be the end for our blue planet. All over the heavens, we can see the remnants of stars like the Sun. Called planetary nebulae, these spectacular formations are made by the gases that once formed the star's atmosphere. Immense stellar winds blast much of its outer atmosphere into space. In the center of each, a small hot star, a few thousand kilometers across, what astronomers call a white dwarf. It's all that remains of the original star's core. In the last few billion years of its life, the dying sun will transform the region of space surrounding it. Outflowing gas will form a spectacular glowing cloud, a stellar shroud of immense proportions. Deep inside will be the remnants of worlds we call the solar system, and the cosmic ash ball that was once the sun. The life of our star will end, not with a colossal bang, but with the creation of a magnificent stellar tomb, a fitting monument to a star that gives us life. Fortunately for us, the death of our sun is billions of years away. We have many more sunrises and sunsets to enjoy. A sunset is simply the Earth turning us away from our star. Sunset gives birth to another night, another chance for us to peek out, to explore, and to marvel at the secret lives of stars.